Okay, guys, so today we are going to be talking about blood pressure and we'll be looking at heart sounds also. So if we were in class, we would be measuring these things using the blood pressure cuff, which is called a sphygmomanometer. I'll go over that in a minute. And we would be hooking ourselves up to the BioPAC carts, but we're not in class, so we're not going to be doing that today. We'll be just doing it this way, which is fine. So what I've done here is I have drawn out an EKG. So just remember P, Q, R, S, T. That's one cardiac cycle. And then we have another second cardiac cycle here also. Again, just to remember, atrial systole happens around the middle to the end of P, stops around the Q, and ventricular systole, where the blood is getting pushed out of the ventricles, is happening between the S and the beginning of the T. So there are sounds associated with all of these activities in the heart, whether we're having systole in the atria or the ventricles, or when we're having diastole, which is everywhere where the chamber isn't having systole. We'll still be hearing noises, and those noises are from the valves opening, the valves closing, and then also just a passive trickling of blood. So what would have happened if we had been in class and you would have been hooked up to the EKG is you would have got your EKG that looks like this, and then you would have had this kind of greenish line with little blips above it, and each of the little blips refers to a sound. Now the sounds are numbered according to where they happen. So the first sound is associated with R, the second sound is associated with T, the third sound is the diastasis period. That's where nothing is contracting. There's no depolarization or repolarization, just that flat spot between cardiac cycles. And then the fourth sound is associated with P. So you see those 1, 2, 3, 4 as those little blips on the green line above. What you would need to know, so what's important to take away from this is what's happening during those sounds. So what you're actually hearing when you hear the sounds, which is listed down here. So sound number 1, your AV valves close and the semilunar valves open. And think about when that's happening. That's happening during R, or just a little bit after R. So when the ventricles are beginning to go into systole. So those AV valves are closing to prevent backflow back into the atria. The semilunar valves are opening so that you can push the blood through into the pulmonary trunk and the aorta. Now heart sound number 2, associated with the T. So this is where the ventricles are relaxing. We don't want the blood to fall back down from the aorta and the pulmonary trunk. So those semilunar valves will close and prevent that from happening. So that's what's happening at sound 2. Sound 3, there's no contraction happening in the heart in any chamber, so all we're hearing is passive filling. That's that diastasis period. So blood just trickling in to the heart. So it's going to be kind of a small sound. And then P, number 4, that is when the atria are going into systole. So we'll be having the AV valves open so that we can have the blood going from the atria to the ventricles. So that's the heart sounds part of this lab. So it was pretty straightforward. Not too much going on there. One thing that we would have done also is practice measuring delta T. Remember, delta T is change in time. So just a quick review on that. If I were to say, what is the delta T between the end of atrial systole, which would be the Q, to the beginning of ventricular systole, that would be the S, you would calculate how long that time was. And if we wanted to get, say, the heart rate, we would find the delta T from one R to the next R. Then we would do that number and do 60 divided by that number. And that would give us our heart rate in beats per minute. So it's a good idea to download some EKGs. Just do a quick Google search, do images, and you'll find a lot of EKGs, and just practice measuring delta T there. Now for the other part of today, so for our lab exercise this week, is blood pressure. So to measure blood pressure, you're going to use a blood pressure cuff, which is called a sphygmomanometer. So that is a nice vocabulary word to remember, and to remember how to spell. So that's one where we always get interesting spellings on that, but just practice it a few dozen times and you'll get it straight. The sphygmomanometer, that's that cuff that wraps around your arm, and what it does is it constricts your brachial artery, which we all know when you get that blood pressure cuff on you, that sphygmomanometer on you, you feel it squeezing your arm really, really tight, and it cuts off the blood flow in your brachial artery. Then when you let it go, if you think about the last time you got your blood pressure taken, you can almost feel like a pulse going through that brachial artery. And that's the turbulent flow from the blood that's been backed up behind that blood pressure cuff being allowed now to go down through your brachial artery. And it makes a sound because it's going to be rolling, more of a turbulent flow than a smooth flow. And it begins at the highest pressure. You'll start to hear this sound, this little click, click, click sound, or a little whooshing sound. It's a very soft sound. And this is what you would be using the stethoscope. You'd be putting it on the inside of your elbow, listening for that first sound, which is called the Korotkoff sound, which relates to the systolic pressure, or the highest pressure. Then that sound will continue in a rhythmic, kind of a pulse-like fashion, just this little click, 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 as you go through until the blood flow smooths out. And the last Korotkoff sound you hear will represent the diastolic pressure. So you hear the first Korotkoff sound at the systolic pressure, you hear the last Korotkoff sound at the diastolic pressure. And if you've ever watched the little gauge when you're getting your blood pressure taken, or if you've ever taken blood pressure, probably a lot of you have taken blood pressure, you'll see that little pressure gauge kind of make little ticks like that as it goes down in pressure. And that's showing those Korotkoff sounds. Now, the word auscultation, another definition. This is just a big word that means to listen. So you're using listening to get your blood pressure, to find your blood pressure. A review from what you've probably learned in lecture is also part of this lab, is finding the mean arterial pressure. This is the equation here. So this is the one in your lab book. And this is another one that you come out to the same answer with this equation. So let's just go over them really briefly. Let's say, just use a blood pressure of 120/80. That's a nice basic blood pressure. So first thing you want to do is get something called the pulse pressure. You just do systolic pressure minus diastolic pressure. So that would be, let's say we were doing 120/80, so that's 120 minus 80 equals 40. So our pulse pressure is 40. Then we plug it into this equation, which is the diastolic pressure, so 80. And we add to that pulse pressure divided by 3. So that's 40 divided by 3. That number, I already did it with a calculator before I started this, so it's 13.3. We'll just leave it at that 0.3. It would keep going with 0.3s, but so we do 80 plus 13.3, and that gives us 93.3. And that would be in millimeters of mercury. And that would be our mean arterial pressure. Now try it plugging it into this equation, where we just do the diastolic pressure times 2. Then we add in the systolic pressure. Then we divide all of that by 3, and you should come up with 93.3. And then you can choose whichever version you like better, whichever one you remember. It doesn't matter how you get to the right answer, as long as you get there. That's good. So that is it for lab today, or this whole week, really. So it was going to be a pretty light lab, so that's good, considering, you know, this is our first week doing remote learning. So hopefully the lectures will get a little bit better as time goes on. My document camera is on the way, so we will be able to have a little more of a sophisticated setup here. But for this, read over those PowerPoint slides that we have posted on Blackboard. They'll have this information. They'll have this information. Make sure you go back over your EKG notes. That's the thing that you really want to spend a lot of time on. This is pretty straightforward. Shouldn't take you a long time. It's the EKG stuff that you really want to be working on, measuring delta T, finding heart rate using just a plain old EKG like this. And then all those notes about the pathologies, like the changes in Einthoven's law, if you had too great of an electrical axis or too low of an electrical axis, all of those sorts of things. The PVCs, the heart attack, Lown-Ganong-Levine syndrome, Wolff-Parkinson-White syndrome, all those things, everything that's in the notes that are posted on Blackboard. Just make sure you study those for this week. And then I will have more videos posted for you for next week. Okay, have a great week, you guys. Talk to you soon. Bye.